First you separate, and then you integrate. Just follow these steps, and you will do great. First you separate, and then you integrate. Just follow these steps, and you will do great.
Here's the season to be serving.
When I was solving equations, I was feeling amazing.
All right, greetings. Welcome to our second video on area between curves. The second video, we're just going to work out a couple of additional examples. We already laid the groundwork in the first video, and we just cut it into two videos, not to make the first video overly long. So in this video, again, we're just going to work out two examples. The first example would be pretty similar to what we looked at in the first video, and then the second example will have a slight difference. So let me go ahead and read the problem. So it says, find the area of the region between the curves F and G from 0 and 2. And of course, you know, these can be written a little differently. Sometimes it may say find the area, or find the area of the region enclosed by f of x, g of x, and x equals 0 and x equals 2. You know, it's described like that. It can be described in different ways. And of course, we don't always have to use f and g. We can call the function various different other things, including y. So just understand it can be written in different ways. So again, you know, when we have to find the area between curves of two functions and they give us the integral to find the area between, first thing we want to make sure is that the two functions don't intersect between that particular interval. So I'm going to find a point of intersection of these two functions, and if one or more of those intersections is between 0 and 2, then I'm going to have to do more than one integral. So let's set these equal to each other and see where they intersect. So we'll say 12 minus x squared is equal to x. So let's just move everything to the right, and that'll be x squared plus x minus 12 equals 0. And that's a quadratic that we can easily solve via factoring. So that's going to be x plus 4 times x minus 3, which means the solution is -4 and +3. So those are the 2 points of intersections. Now, if you notice, both of these points are outside of the given interval. So we don't have to worry about it. So then we can just do one integral from 0 to 2 of the difference of the two functions in no particular order. Again, maybe in this one, it's a little easier to understand which function is on top and which one is on bottom. So I guess this one I will do the proper order, because 12 minus x squared, you know, that's a upward facing parabola whose vertex is at 0, 12, and y equals x is just a horizontal line at a 45-degree angle coming like that from the origin. So from 0 to 2, f is going to be on top and g is going to be on bottom. So I will do it in a proper order. And the way I did it, you know, the way I solved this, you know, in the previous video, I said, you know, once you have this guy equal to 0, that's pretty much the difference of the two functions. But the way I did it, you know, this was f and this was g, and I brought f over here. So this is actually g minus f. And so if I want to do it proper, if I want to do f minus g, and it's just going to be different signs. So it's just going to be -x squared minus x plus 12. So that's properly what f minus g is. Again, when you subtract, it just changes the sign. The difference between 5 minus 2 and 2 minus 5 is a sign. All right, so let's go ahead and integrate and see what happens. So again, this is what I'm going to integrate from 0 to 2. And since I did it in the proper order, I don't have to worry about an absolute value sign. And since the points of intersections are not in this interval, I only have to do one integral. All right, so we're integrating from 0 to 2, -x squared minus x plus 12. And this is a nice, easy problem to do for a couple of reasons. One, we only have to do one integral. Two, it's polynomial, and one of the limits is 0. So it means when I plug in 0, I'm going to get 0. So really, after I integrate, after I find the antiderivative, I only have to plug in 2. So it's a nice little problem here. So let's find the antiderivative. So for negative x squared, we'll get negative x cubed over 3. For negative x, we'll get negative x squared over 2. And for 12, we'll get 12x to be evaluated from 0 and 2. So when we plug in 2, well, we'll get negative 8 over 3. And then when we plug in 2 to this guy, that'll be negative 4 over 2, which is just negative 2, and then plus 24. So we have negative 8 over 3 plus 22. So we can make 22 66 over 3. So it's negative 8 over 3 plus 66 over 3, which is 58 over 3. All right, so that's how you find the area of that particular problem. And we're going to do one more example on this part 2 video. And on the second example, it just says find the area of the region bounded by the graphs of f and g. It doesn't tell me on a particular interval to find the area. It just says find the area bounded by the graphs of f of g. So if they don't give you a closed interval to find the area on, then what you do is you find the area between where the two graphs intersect. So, if you just think about a rough sketch of this situation, this is a downward facing parabola, and this is a line with a positive slope. So the graph is something like this. And so again, when they don't specify the area, they want this guy right here. So this is the area they want. And so if you see, the area is enclosed with the 2 points that the graph intersects. So when they don't speculate, the interval on which to find the area, you're going to find where the two functions intersect, and you're going to find the area between those two guys. So again, the area should be a closed region that you can find the area. For instance, I couldn't find the area from this point on to the right because this is never ending. Even on this side, this is never ending. So we're finding the area where it's a defined region closed by the 2 points of intersection. All right. So of course we need to find the 2 points of intersection, and then we'll simply integrate between those two numbers. And this is another one where it's pretty easy to see which function is on top and which one is on bottom. In this case, f is on top and g is on bottom. All right, so let's first find a point of intersection. So let's set these two equal to each other. And so 2 minus x squared equals x. And so again, I'll move this stuff over, and we'll have x squared plus x minus 2 equals 0, which is x plus 2 times x minus 1 equals 0, which means the points of intersection are -2 and 1. So we're going to integrate from -2 and 1. And again, we're going to integrate f minus g. And again, this is f and this is g. So the way we did this setup, we moved f over here. So this is g minus f here. And so that means f minus g is just going to be the opposite signs of this. So it's going to be negative x squared minus x plus 2. So this is what we're going to integrate from -2 to 1. All right, let's go ahead and integrate. So we're integrating from -2 to 1, negative x squared minus x plus 2. All right, there it is. So let's go ahead and find the antiderivative. So for negative x squared, it's negative x cubed over 3. For minus x, it's minus x squared over 2. For 2, it's 2x to be evaluated between -2 and 1. All right, so let's plug in 1 and see what we get. So for 1, we'll get -1/3 minus 1/2 plus 2 minus, it looks like this pen is dying. So I'm going to switch to a different pen. It's going to change the color. Still fine. And so now we're going to plug in -2, and -2 cubed is -8, but that makes it +8. So +8 cubed. And then -2 squared is +4. And 4 over 2 is 2, but that minus sign makes it -2. And then -2 times 2 is -4. All right, so let's see what we have here. So we can do -1/3 minus 8/3. That's -9/3, which is -3. Let's see what we have with whole numbers. This is -6. And we're doing minus -6. So that's +6 plus a +2. That's 8. And the only thing we have left is -1/2. So -3 and 8 is 5. So you have 5 minus 1/2. That's 10 over 2 minus 1 over 2. That's 9 over 2. All right, so that completes the second video on area between curves. And on the second example, again, when I don't give you an interval to find the area between, you'll get the 2 points of intersections of the 2 curves and integrate between those 2 numbers. We will see you next time.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe-to-toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.